1 second. That's all we're talking about. Not a day, not an hour. Just a single tick of the clock. Now imagine that in that 1 second, the Earth is pulled into a black hole. Then, an instant later, it's spat back out, whole, spinning exactly where it was. It sounds harmless. 1 second is nothing. You blink and it's over. But the truth is, if the Earth spent even 1 second inside a black hole, there would be no Earth left to spit back out. And to understand why, you have to understand what a black hole actually does to the things that fall into it. Let's start at the edge. A black hole isn't a thing you can touch. It's a region of space where gravity has become so overwhelming that nothing, not even light, can climb back out. The boundary of that region is called the event horizon. It's not a surface. It's a line of no return. Cross it, and the rest of the universe is closed to you forever. For a black hole the mass of a large star, that boundary might be just a few kilometers wide. And the moment any part of Earth crossed it, the countdown to total destruction would already be over. Because inside a black hole, 1 second is not really 1 second at all. Here's the first thing that breaks. Time. Near a black hole, gravity is so intense that it warps time itself. This isn't science fiction. It's been measured. Clocks tick slower in stronger gravity, an effect predicted by Albert Einstein over a century ago and confirmed countless times since. The closer you get to the event horizon, the more time stretches and distorts. So the 1 second we imagine from the outside would not match the experience of the Earth falling in. From a distant point of view, the Earth might appear to slow down, redden, and freeze at the edge, never quite seeming to cross. But from Earth's own frame, it would plunge inward fast, towards something far worse than being frozen in time. That something is the singularity. At the center of a black hole, according to our current understanding, all the mass is crushed into a single point of infinite density. A place where the known laws of physics simply stop working. Everything that falls in is pulled toward it. Not might be. Will be. There are no stable orbits inside a black hole. Once you're past the event horizon, every possible path leads to the center. Down is the only direction that exists. And on the way down, the Earth would face a force with a strangely gentle name. Tidal forces. Gravity gets stronger the closer you are to a mass. Normally, the difference is tiny. But near a black hole, the gravity on the near side of the Earth would be dramatically stronger than on the far side. The planet would be pulled from both ends at once. Physicist Kip Thorne, one of the world's leading experts on black holes, helped popularize the vivid term for what happens next. Spaghettification. The Earth would be stretched. Not shattered like glass, but drawn out like putty pulled between two hands. Mountains, oceans, the molten core, all of it stretched into a long, thin stream of matter spiraling toward the center. And this wouldn't take a second. It would begin the very instant Earth crossed the horizon. So could it ever come back out? This is the part that surprises people the most. No. Nothing comes back out of a black hole. That's the entire point of the event horizon. To escape, you'd need to travel faster than light, and as far as we know, nothing can. Once the Earth crossed that line, the idea of 1 second later loses all meaning. There is no path back to the outside universe. There is no reverse. But here's where it gets even stranger. The Earth wouldn't simply vanish without a trace. The mass and energy that made up our planet wouldn't be destroyed. It would be added to the black hole. The black hole would grow ever so slightly more massive than before. In a sense, Earth wouldn't be gone. It would become part of the black hole itself, its matter smeared across the singularity, its information scrambled in ways physicists still argue about to this day. In fact, one of the deepest mysteries in modern physics, known as the black hole information paradox, asks whether the information that made up the Earth, every atom, every memory, every fingerprint, is truly lost forever, or whether it's somehow preserved in the radiation a black hole slowly gives off over unimaginable stretches of time. Stephen Hawking spent decades wrestling with this very question. But for us, standing on the surface, none of that would matter. There would be no warning shudder, no dramatic buildup. The tidal forces would tear the planet apart faster than any signal could travel across it. You would not feel the Earth enter a black hole. You would simply cease, along with everything you've ever known, in far less than the second we imagined. And yet, here's the reassuring truth. This will never happen. Black holes are not roaming the galaxy hunting for planets. They don't lurk nearby waiting to swallow us. The nearest known black hole is over 1,500 light-years away, an almost incomprehensible distance. Earth is in no danger from it, or from any other, for as far into the future as we can meaningfully imagine. So the whole scenario, Earth diving into a black hole for 1 second, is impossible on 2 levels. There's no black hole close enough to do it. And even if there were, there would be no coming back. But thinking it through reveals something profound about the universe we live in. A single second, the smallest sliver of time we barely notice, is enough for gravity to unmake an entire world. The same gravity that gently holds you to your chair, that keeps the moon in its orbit, that pins the oceans to the planet, is, in its most extreme form, the most destructive force in existence. So the next time a second slips by unnoticed, remember what a second can hold. In one place in the universe, it's just a heartbeat. In another, it's long enough to erase a planet and everyone who ever lived on it. If you enjoyed the video, don't forget to subscribe to the channel and hit the bell icon so you never miss a new video.